Hello once again, Science 9 fam. We are here again to solve for letter B of the same problem number 1. Okay, so we have the same given. We have 20 meters per second and we have 25 degrees. And in letter B, what's being asked for is the total flight time. Alright, so in letter B, we have our given of 20 meters per second. Theta is equal to 25 degrees. And the asked for is your t. We need the t. However, we cannot solve for t without figuring out the hidden givens. Again, in these kinds of word problems, we need to be able to figure out what's hidden amongst the problem. We have 3 types. We have our max height, hidden given. We have our initial range and initial height. And we have our final range and final height. These are our hidden givens. In the case of maximum height, we don't really need it for this problem since what we're looking for is the t. And we have these given. It's not really that necessary to get the maximum height. It's not being asked for. So let's not bother ourselves with that one. For number 2, the initial x or y, the initial range or height, we can get that by imagining what the problem looks like. If we look at how the projectile travels, the trajectory of the projectile is, wow, I can't draw like so. I can't even draw the arrowhead on the end of the arrow. Perfect. Excellent. Alright, so if we start here, again starting there, alright, we get our x sub 0, or your initial range, is equal to 0, and your y sub 0, or your initial height, should also be equal to 0. This is our hidden given for x sub 0 and y sub 0. This should be equal to 0. Another hidden given is your final x and final y. If we look at the final resting place of your projectile, we should be able to get the final y, which should be equal to, again, if it hits the ground, your height when you're on the ground and you can't get up is 0. Just like your grade. I'm joking. Let's hope you're not 0 in grade. So this is our second hidden given that is applicable to this problem. So let's write y is equal to 0. And now we've got our hidden given in order. So we have 2 extra values that are both 0. We'll see in a bit that this makes our formula much easier to deal with, even though the formula itself looks intimidating af. Alright, so again, if we have our given and are asked for, the formula that we need, we decide by what is absent in the problem. So again, our 3 kinematic equations are the following. Okay, the first one has no need for y, the second one has no need for vy, and the third one does not need t. So take note that those vy and y, these can also be substituted for x. So again, we're looking at if it needs vx or vy. Does it need range or height? And does it need time? Again, these 3 things will decide what formula we'll use. Definitely, we need the t, because that's what we're looking for. So definitely we need the t. For x or y, we have the value of y, which is 0. So we have that. While for vx or vy, if you look here, we only have initial velocity. We don't have the final velocities. So this is the one that is absent. So we decide the kinematic equation based on which one does not need vy. And that is our second equation. Take note that our second equation is quadratic. It has an exponent of 2. So I hope you guys remember your Math A with Sir June. All those math camp war flashbacks, they're all gonna be useful now. Who knew, right? It has an actual use in your life, which is surviving science. Anyway, so our second formula, if we write down our entire second formula, it is y is equal to y sub 0, or initial height, plus v sub 0y times t minus 1/2 gt squared. Oh boy, what an intimidating formula. But when you write it in solution, when we substitute the values, y is equal to 0. And that should be equal to y sub 0, which is also 0. My guy. So 0 plus, and this is where we have to do our vector resolution. V sub 0y, we don't have that in our given, but we can get it from v sub 0 and theta. Again, if we have v sub 0, that is our value for r. Again, it's just r sine theta in order to get the y component. So if we get r sine theta, we have 20 times sine of 25 degrees, which we already did in our last problem. So where I'm just gonna go ahead and give the value. It's 8.45 ... So we'll use that for that value, 8.45 multiplied by t. Again, we don't know t. Minus 1/2 9.8. Again, 9.8 is our value for gravity, and our time squared. Okay, so this is our initial equation that we will have to simplify. Now, if you remember your quadratic equations, it becomes much simpler now that we have 0 in this case. Because if we simplify this, we get 0 is equal to 8.45 t minus 1/2 of 9.8 is just 4.9. Okay, so again, this one is just 4.9 multiplied by t squared. Hallelujah! This is very simple to factor out. Okay, so if 0 is equal to this, we can factor out the t. Ilabas natin yung t. We get t times 8.45 minus 4.9t is equal to 0. Now, in order for this to become 0, we need either this to be 0 or this entire thing to be 0. That gives us two possible values for t. It can either be 0, such as in this case, or in this case, 8.45 minus 4.9t. 8.45 minus 4.9t. If we make that equal to 0, again, if we solve this part, oh my gosh, my whiteboard is too small for this. We get t is equal to, again, your t is equal to 8.45 divided by 4.9, which is equal to around 1.72. Again, you have two possible values for t, 0 and 1.72. Now, we have to pick between these two values. So just use your common sense. Okay? Is the total flight time of the object gonna be 0 seconds? If you throw an object, if you yeet something, is that gonna fly for 0 seconds, like absolute 0? No! And so, we find that 0 is an extraneous solution, so this should be our answer, 1.72. If we look at our given, the only unit for time we see in our given is the time. Seconds. Again, the unit seconds and meters per second. So, our final unit should also be seconds. Alright, so, rewriting all of that into our final answer, which should be in sentence form. Again, take note of your number of significant figures and your unit. So, our final answer in this case will be the total time is 1 point. How many significant figures? If we take this to mean that there is a dot there, and maybe they just didn't write the dot, we have two significant figures there. And in this case, we have two significant figures there. So let's have our answer in two significant figures. 1.72 will be rounded down into 1.7. Alright? 1.7 seconds. This is our final answer. So once again, don't forget to find the hidden given. Determine the proper formula to use based on what is not there. And finally, don't forget that you'll need to know how to use your quadratic equations and possibly your quadratic formula in order to arrive at the answers. If you have any questions, don't hesitate to message me. I am online because I have nothing to do with my life. Alright, so I'll see you guys or talk to you guys next time. Toodaloo.